Sequences, unit test review. Find the explicit formula for their arithmetic sequence. So let's go ahead and turn on the writing screen here. So the very first term is 170, the second term is 85, the third term is 0, and the fourth term we see is a negative 85. Looking at these first, we notice that the numbers are getting smaller. From 170 to 85, from 85 to 0, from 0 to a negative 85. So the big tip off here that really tells me what's happening here is the 85 to the 0. So 85 subtract the 0. Or better yet, let's do it this way. It should be the other way around. It should be the 0. So we're going to take the 0 here and subtract it by the second term, which is 85, which is a negative 85. See, if I take the 85, which is the second term, and subtract it by 170, that's also a negative 85. If I take the last term, which is a negative 85, subtract that by 0, the 0 doesn't change the negative 85, so it keeps it at a negative 85. So what is our first number here? Well, the first number is 170. So we're going to lead with the 170 here. And then we're going to say minus 85, because remember, this is a arithmetic sequence, so it's like addition or subtraction here. So this is going to be a minus 85, and then we want to go parentheses n minus 1, and this is not an exponent that stays at the same level with the other numbers. So 170 is our first, our rule here is a negative 85, and then n minus 1. Okay, right here we have h of 1, and we want to find negative 2. And now notice when you look at the formula, you scan the formula here, it's got a bunch of n's here, especially at the end. So that tells me that we have to plug into this formula here. So we're going to say h of n is equal to h of n minus 1 plus n. But since this is h of 2, we're going to put a 2 in for all the n's. So we're going to say h of 2 now is equal to h of 1 plus 2. Now we're going to go back, look at the formula over here on the top. This tells me what h of 1 is. H of 1 is a negative 2. To this we're going to add the positive 2. So h of 2 is equal to negative 2 plus 2, which is 0. So 0 should be our answer. Okay, so right here we have the following formula, and we want to find the second term. We only have one formula to work with. So we're going to say c of 2, because that's what we're looking for, the second one, is equal to a negative 6 times a negative 1/3. Now instead of saying n minus 1, we're going to say 2 minus 1. So now we're going to say negative 6 times negative 1/3. Now this is to the first power, so that's not needed anymore, so we don't have to really do any changes to this fraction, so we can leave it as a negative 1/3. We put the negative 6 over 1. We can go ahead and multiply, so we get a positive 6 over 3, which is 2. So c of 2 is equal to 2. Okay, we have the following arithmetic sequence. So this is 1, this is 2, this is 3, and this is 4. So we want to figure out what's the next number in it. Well, If we take the 2, subtract the 0, that's 2. If we take the 4, subtract the previous number, which is 2, that's also 2. If we take the 6, subtract the previous number, which is 4, that's 2. So what are we doing here? We're adding by 2. So we got 6 plus 2. That's the last number we left off with was 6. So 6 plus 2 is 8. So our answer is 8. Okay, we have the following sequence here, and it's a arithmetic sequence. So this is my first, this is my second, this is my third, and this is my fourth. So my very first number, b of 1, would be 4. So 4 would go in that box there. Now since it's arithmetic, we're adding here, so the numbers are increasing. So we take 22, subtract 4, that's 18. We take 40, subtract 22, that's 18. We take 58, subtract 40, well, that's 18. So what's happening here is we're adding by 18 to get the next larger number. So in the first box we're going to put down the 4 because that's what we started with in the sequence here, was this 4. And then what we're doing is we're adding 18 each time. Notice you do not have to put down the plus 18 because the plus sign is there. Only thing you have to do is just press an 18 into the box. Okay, we have the explicit formula for the geometric sequence. So the first term is negative 8, negative 40, negative 200, and negative 1,000. So the very first number we start with is a negative 8. Now this is multiplication. So we can take the negative 40 divided by the first term, which is negative 8. That gives me a positive 5. Now we can take the negative 200 and divide it by the negative 40. Now there's a trick here with the zeros. You can cross out 0 for 0. So now you're looking at negative 20 over 4 over a negative 4, which is also a positive 5, so it works there. Now the last one, you have a negative 1,000 over a negative 200. You can cross out these zeros here, so what you have left is a negative 10 over a negative 2. Negative 10 over negative 2 is positive 5. So what we're doing here is we're starting with the negative number, negative 8, and then we're multiplying by a positive 5. And then since this is a geometric, we want to go n minus 1. And that's going to be more of an exponent. So the very first number here is negative 8. We're multiplying. Now remember, again, I guess this is a flaw with Khan Academy. You have to put these in parentheses. You just can't leave it as a positive 5, because I find that does fail sometimes. You come out of parentheses. Now remember, with the geometric, you got to use the n minus 1 as an exponent. So you got to press the AB key, and what I would do is use parentheses again, because by doing so you maintain the n minus 1 as an exponent. If you don't do that, your n will be an exponent and the minus 1 is going to drop. So let's check this. Okay, let's go on to the next question. So we have h of 1 is equal to negative 75, and we want to find the explicit formula for h of n. Now right here, this is a Rithmatic, and this is my first term here because I know that's 1, but I know this is a Rithmatic because that's a minus 10 there. So we would start off with the very first term, which would be negative 75. Our rule is a negative 10, and then we want to finish with the n minus 1, but this does not become an exponent. It still stays as, the same level with the negative 75 and 10. So we're going to go negative 75, and then we have the minus 10 because that's our rule, minus 10, and then we're going to go parentheses n minus 1. So again, our first term is negative 75, our rule is a negative 10, everything stays at the same level because it's arithmetic, so it's n minus 1. Okay, complete the recursive formula for the geometric sequence. So right here, this is my first term, second term, third term, and my fourth term. So the very first number in here is a negative 0.56, so that's going to be C1. Now this is geometric, so we know this is multiplication. So we're going from a negative 5.6 to negative 5.6 to negative 56 and negative 560. So what they're doing is they're moving the decimal over one place to the right. So what they're doing is they're actually timesing by 10, because 10 times negative 0.56 times 10 would slide the decimal over one place to the left. Negative 5.6 times 10 would slide the decimal over and make it into a negative 56. If we times this by 10, this would give me the negative 560. So what our rule is, we're actually multiplying by 10 because the movement is with the decimal, and decimal is one place to the right. For every place that you move a decimal, you put down a 0. Since we're only moving it one place to the right, we're only using 1 0. So the first box is going to show us a negative 0.56, and the next box is going to be a positive 10. Okay, Barack received 12 rare stamps as a gift from his grandfather, so he decided to start a stamp collection from the following week onward. Barack added 4 new stamps to his collection each week. Let G of n be the total number of stamps in Barack's collection in the nth week of the collection. So G sequence, what kind of sequence is this? Notice the word here, the key word here is added. So since he's adding, anything with to do with addition is arithmetic. Now he received 12 stamps, so he started off with 12. So that's going to go into the first box. So the first box is going to be 12. The second box, he added 4 to it, so this is going to be a plus 4 because there's an increase of 4 each week, so this is a plus 4. So let's check this. Okay, what is the next term of the geometric sequence here? So right here we have the 27. This is going to be my first term, this is my second term, and this is my third term. Now notice the numbers are increasing here because you've gone from a fraction of 27 over 16 to 3. Also there's an alternation here. It's positive, then negative, then positive. So that tells me that the number is going to be a negative. So let's take the 3 and let's go ahead and take this 3 here and divide it by the number in front, which was a negative 9/4. So when we do division, we put a 1 here, so we say negative 3 over 1 times, now we're going to flip our fraction, let's leave our negative sign on top, and this is actually a positive 3 here. So that would be a positive 3. So let's leave our negative on top, and let's write this as 4/9. So right here we'll do our multiplication. So this is going to be a negative 12 over 9. Now negative 12 over 9, the 3 will go into both. So 3 goes to negative 12, that'd be a negative 4/3. So it looks like it would be a negative 4/3 that we're timesing by. So let's go ahead and check that. Let's say that we took the negative 9/4, and I believe that we're timesing by a negative 4/3 each time to get the next number. So we're going to take this negative 9/4 and we're going to times it by the negative 4/3. So this is going to be 36 over 12, which is 3. So that is true. So we are multiplying by negative 4/3. So now let's take the 3, That was the last number we left off with. Let's put the 3 over 1, and let's times this by negative 4/3. So when we multiply this out, we're going to get a negative 12, and that's going to be a negative 12 over 3, which would actually become a negative 4. So again, we're multiplying each time by negative 4/3. So we'd start off with the last number, which was 3. That would give me negative 12 over 3, which would be negative 4. So let's go ahead and try negative 4 to see if that's our next number. Okay, so we have the following formula here. We want to write this recursive into an explicit. So our very first term here is 2.7. So we want to start off with is 2.7. Now you see right here, this is what I'm looking right after parentheses. What's happening here? Well, we're multiplying. So we're going to times this by 6.1, and then we're going to use the exponent of n minus 1. So that's basically the way our formula is going to set up. So we're going to take the 2.7. We're going to multiply. Now remember, with the Khan Academy, you've got to use parentheses on the second number here. If you don't do it, it's a good chance it's going to be wrong. So we're going to put the 6.1 into the parentheses. Now we're going to use the AB key to bring it up to an exponent. We're going to use the parentheses so we can keep the n minus 1 as an exponent. Okay, what is the next number in the geometric sequence here? It's my first term, my second term, and my third term. So we're going to take 6 divided by 3 is 2. We're going to take 12 divided by 6, because that's right in front of the 12, that's also 2. So this is telling me that we're multiplying by 2. So the last number we left off with was 12, so 12 times 2 is 24. So 24 should be the missing number. Okay, so we have the following. A of n is equal to a negative 6, then we have minus 4, then we have n minus 1, and we want to find the fourth term here. So we want to say a of 4 is equal to a negative 6 minus 4. Now this n minus 1, that n right there is going to become a 4 minus 1. So now we're going to say negative 6 minus 4, that's going to become 3. So now we're going to say negative 4 times 3 is a negative 12, so we get a negative 18. So a of 4 is equal to a negative 18. So again, you want to use this formula right here. Wherever there's an n, it's going to become a 4. So we're going to say a of 4 is equal to negative 6 minus 4, then we have 4 minus 1. From there that turns to a 3. From here we multiply to get to negative 12. We take negative 6 minus 12 is a negative 18. So negative 18 should be my answer.